Grade beams are essential components in many construction projects. They are horizontal beams made of reinforced concrete. These beams connect foundation walls, piers, or other structural supports. Think of them as bridges that distribute the weight of a building evenly across the foundation. Grade beams play a crucial role in preventing settlement and ensuring the stability of a structure. They are especially important in areas with weak or unstable soil. Without grade beams, buildings constructed on such soils might sink or crack over time. Imagine a house built on soft clay. The weight of the house could cause the clay to compress unevenly. This could lead to cracks in the walls and foundation. Grade beams help to prevent this by spreading the load of the house more evenly. This ensures that the weight of the house is distributed over a larger area, reducing the pressure on any one point. Grade beams are a cost-effective way to improve the stability and longevity of buildings constructed on challenging soil conditions. Grade beams provide numerous advantages in construction projects. They are particularly beneficial in areas with poor soil conditions. Grade beams help to prevent differential settlement. This occurs when different parts of a building settle at different rates. Uneven settling can cause significant structural damage. Grade beams mitigate this risk by distributing the building's load evenly. This ensures that the foundation settles uniformly, preventing cracks and other issues. Another key benefit of grade beams is their ability to handle heavy loads. They effectively transfer the weight of the building to the foundation. This includes the weight of the walls, floors, roof, and any contents. By distributing this load, grade beams reduce the stress on individual foundation elements. This helps to prevent foundation failure and ensures the long-term stability of the structure. Constructing grade beams involves a systematic process that begins with excavation. The first step is to excavate trenches to the required depth and width. The dimensions of the trenches depend on the design specifications of the grade beams. Once the excavation is complete, formwork is installed. Formwork is a temporary structure that acts as a mold for the concrete. It is typically made of wood or metal and is carefully positioned to create the desired shape and size of the grade beams. After the formwork is in place, steel reinforcement bars, known as rebar, are placed inside. Rebar strengthens the concrete and helps it resist tensile forces. The rebar is tied together with wire to create a secure framework within the formwork. The final step is to pour concrete into the formwork. The concrete is typically delivered to the site in a ready-mix truck and poured carefully to avoid air pockets. Once the concrete has cured, the formwork is removed, revealing the finished grade beams. Section 4. Design considerations for grade beams. Designing grade beams requires careful consideration of several factors. One of the most critical factors is the soil conditions at the construction site. The type of soil, its bearing capacity, and its moisture content all influence the design of the grade beams. For example, in areas with weak soils, wider and deeper grade beams may be required to provide adequate support. Another important consideration is the load requirements of the building. This includes the dead load, which is the weight of the structure itself, and the live load, which is the weight of people, furniture, and other contents. The grade beams must be designed to handle both the dead and live loads without excessive deflection or stress. Building codes and standards also play a crucial role in grade beam design. These codes provide guidelines for minimum dimensions, reinforcement requirements, and other design parameters to ensure the safety and structural integrity of the building. Section 5. Comparing grade beams to other foundations. Grade beams are just one type of foundation system used in construction. Other common foundation types include slab-on-grade foundations and deep foundations. Slab-on-grade foundations are a simple and cost-effective option for well-drained, stable soils. They consist of a single concrete slab poured directly on the ground. However, slab-on-grade foundations are not suitable for areas with expansive soils or high water tables. Deep foundations, such as piles or caissons, are used when the soil conditions are very poor and the building loads are high. These foundations extend deep into the ground to reach more stable soil or rock strata. Deep foundations are typically more expensive than grade beams or slab-on-grade foundations. The choice of foundation system depends on factors such as the soil conditions, the building load, and the budget.